This demo is an explanatory overview of the Machine Control Toolkit solution, which provides control and efficiency to your industrial operations. We are going to see how a network of washing machines across the world can be managed in a centralized way, with just one AI model to detect anomalies. As we follow on, we will appreciate the first part of the demo, which is an explanatory overview of Cordis suite functionalities in this solution. The Cordis suite offers the complete low-code software development platform for machine control applications based on graphic model-driven software engineering. The first step would be to create our low-code model in which we describe the functional decomposition of the system by using a class diagram. We will create a machine called washing machine, and its different machine parts, buttons, lamps, drums, which is also composed of other machine parts like temporary control motor, water control, a couple of pumps. Each of these machine parts have some properties and commands. Like the motor here, for example, which has a start command that accepts the speed parameter, and the stop command. We can also define the behavior of the system by means of state machines. We can drill down to the state machines that control the washing cycle, where we reach features like filling the reservoir with water, heating the water, spinning, stop everything, taking the water out, and centrifuging if needed. We can verify that our model is correct by using the checker functionality to build into the modeler. In this case, we don't have errors or warnings, just a few variables that we have not used in the model, and the modeler warns us about it. Then, we can generate the code and compile it, which is already done, to speed up the process, and connect it to the machine control server, which is a tool that will connect to the controller, and expose all its functionalities to other elements of the suite and also put all the relevant information into a database. Thanks to this, and without writing any single line of code, we can have the machine control dashboard, which exposes the functional decomposition we have used in the model so every machine part can be easily browsed. We can also see all its properties and commands. In this example, we can see that the start command, as in our model, accepts the speed parameter. We can also see in real time what the status of our state machine is, which is the active state. We can also browse the history and go back in time or go back to real time. There is a lot of information available to the user. The digital twin reflects everything that is done, so we don't really need the actual hardware. So, if we trigger a wash, we will see that the digital twin reacts by filling the water level and heating when needed. You will be able to appreciate that the wash will start very quickly. We provide a lot of information to the user, that's why we team up with Toolkit, so they can analyze this data to get information that is actually useful to the user. Another advantage of the use of a low-code model is that we can generate documentation. Using a template, we can generate documents that contain all the information in our models, diagrams, properties, state machines. Everything is stored in this document that can be created in different formats and modified by the users. We have a tool that allows you to browse all the information reflected in the simulation. We call it the trace tool, and we can see that all this information portrays the same names used in the models, like preparing washing, spinning anti-clockwise, clockwise, and so on. We can also go to a very low level in this graph, showing the control signal of our LED light driven by a state machine that blinks an LED. For further information, contact our sales department, sales@toolkit.com.